Hi everyone, so today I'm going to show you how to construct your probability distribution, how to solve for the mean, variance, and standard deviation. So here I have this problem. A box contains 3 red balls and 1 blue ball, and 1 ball is drawn at random. Let the random variable r be the number of red balls drawn where x is equal to 1 if a red ball is drawn, and x is equal to 0 if a blue ball is drawn. So in order to construct our probability distribution, we have to follow 7 steps. First is to identify the experiment. Second, identify the random variable. Third, determine the sample space. Fourth, determine the value of the random variable. Fifth is to construct your probability distribution table. Sixth is that summation of p of x must be equals to 1. Seventh is to make your histogram and probability cumulative distribution. So let's go and I'm gonna show you how to do it. So here we have our problem. So the first step is to identify the problem. The problem in this statement is that it's a box contains 3 red balls and 1 blue ball and 1 ball is drawn at random. So that's your first step, to identify the experiment. The second is to identify the random variable. So we have to look for the random variable here, and the random variable is r. So let's put r, but that's wrong if you only put r. We have to put what does r represents. So r represents the red ball. It says here that r be the number of red balls drawn. R, the number of red balls drawn. Third is to identify our sample space. In order to identify our sample space, we only have one trial because it only says if a ball is drawn. If a ball means it's only singular, so we only have one trial. So this we have first trial. Let's put all the numbers of red balls and blue ball. So we'll have red, red, red. 3 R's for 3 balls, 3 red balls, and 1 B for the indication of 1 blue ball. So let's count how many or how times does a red ball is drawn for each try. So for this try we have 1 red ball. The second we also have 1 red ball. The third is we have 1 red ball, and for the fourth is we have no red ball. We only got 1 blue ball, so we'll indicate and put this as 0. So for our fourth step, to identify the value of the random variable, first we have to put all these outcomes. These are the outcomes. We will put it on our sample space. So R, 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 and B. So we have 4 outcomes. Let's go for step 4. It says here for step 4 that we need to find the value of the random variable. So we'll put R. And here we have the values. We do not need to repeat the repeating numbers. We'll just have to put it, but in order from smallest to biggest. So we'll have to put 0 and 1. So we finally have our values for the random variable. Let's go and construct our probability distribution table. So we'll put are f p of x. F means the frequency. It is the number of how many times the outcome has shown from the trial. So we'll put the values of the random variable, which is 1 and 0, 1 and 0. How many times did the 0 comes out from our trial? So it's only first. So it only appears once. For the value 1, it appears 3 times. So we'll put 3. And we'll add them all. 1 plus 3 is equals to 4. So which means we will put 4 as our denominator for p of x. And we'll just copy the frequency 1 and 3. In order for us to get the summation of p of x equals to 1, we'll have to add all, because summation means adding all. Summation of p of x is equals to 4. So the denominator is just the same, so we'll have to put it directly. 1 plus 3 is equals to 4. So our answer is 1, which makes our step number 6 accurate. Correct, because it's equal to 1. Let's go to our step 6. I forgot. Step 6 is already done. So let's go to our step 7, which is to create your histogram. In order to create your histogram, we have to base on our p of x. So we have the value. So we have the p of x 1/4 and 3/4. We will just have to make the horizontal and vertical line, which is the y-axis and x-axis. Here, 1, 2, 3, 0. For this is our x-axis. What are we going to put in our x-axis? Of course, we are going to put the values of the random variable. So we'll have to put 0 and 1. And for the y-axis, we are going to put the values of our p of x, which is 1/4, 2/4, 3/4. But wait, we don't have any 2/4 in the p of x. We still need to include putting 2/4 because we cannot count and skip to 3. Of course, you can't even count or skip counting if you just skip 1 to 3. So we have to count it to 1, 2, 3. 1/4, 2/4, and 3/4. So we'll have to do our table now. So 0 is equivalent to 1/4. So we'll have to put a graph or bar here. And 1 is equivalent to 3/4, so we'll have to put a bar here too. So we have created our histogram now. And next is we're going to create our probability cumulative distribution. In order to create our probability cumulative distribution, we have to add the p of x. So the p of x of 0, 1 plus 1/4 plus 3/4 is equals to 4/4. And this 1/4 and 4/4 is the one we're going to include for the probability cumulative distribution. So let's create the probability cumulative distribution. 4, 3, 2, 1, 0. Still, for the x-axis, we're still going to put the value of the random variable, which is 0 and 1. And for our probability cumulative distribution, we're going to include 1/4, 2/4, 3/4, and 4/4. Because again, we cannot skip counting 1/4, 2/4, 3/4, 4/4. So 0 is equivalent to 1/4, and 1 is now equivalent to 4/4. So we have to put this. Remember that histogram can always go from up to down, or down, up, and down. But probability cumulative distribution must go from down to up. Okay, so now we are done with our 7 steps. We are going to find and solve for the mean, variance, and standard deviation. In order for us to look for the mean, variance, and standard deviation of the probability distribution we have solved, we will have to look for the mean, which is the expected value, and this is the formula for the expected value or the mean. Mean is equals to summation of x times p of x. Second is to find or look for the variance, which has two formula. And for each formula, they both will have the same outcome. So the first formula is standard deviation to the power of 2 is equals to summation quantity x minus mu to the power of 2 times p of x. The second formula is standard deviation to the power of 2, or oh, I forgot. This is read as variance, and this is read as the mean. Variance is equals to summation of quantity x to the power of 2 multiplied to p of x minus m squared. And this is what we read as the standard deviation. Standard deviation is equals to the square root of the variance. So me personally, I answer and use both of the formula to get more accurate answer. So we will use for the first formula, which is variance is equals to summation of quantity x minus mu to the power of 2 times p of x. So the first thing we will do is to multiply r times p of r. Remember that the x is a variable which can also be changed if your random variable in this statement is also different from what the original formula is given. So the r r r r r so r 0 times 1/4 is 0. 1 times 3/4 is 3/4. So in order to find the mu, we will have to add all x p of x. So we will add 0 plus 3/4 is equal to 3/4, which is in decimal form 0.75. So that's our mu or our mean. The second step is to subtract mu from the random variable. So 0, here's the random variable. 0 minus mu. 0 minus 0.75 is equal to negative 0.75, and 1 minus 0.75 is equal to 0.25. Next step is to square or multiply by itself r minus mu. So negative 0.75 squared is equal to 0.56, and 0.25 squared is equal to 0.06. Next step is to multiply the squared r minus mu to P of R. 0.56. We will convert it back to being to its fraction form, which is 14 over 25 multiplied by P of R, which is 0.1 over 1 over 4 is equal to 7 over 50. 0.06 will be converted or changed into its fraction form, which is 3 over 50 multiplied to P of R. Oh, this is R. P of R, which is 3/4. Then we will have 9 over 200. We will summate all this. So it's 7 over 50 plus 9 over 200 is equal to 37 over 200. In order, this is our standard deviation, but I always use the decimal. So 37 over 200 converted into decimal is 0.19. This is now our standard deviation, 0.19. In order to find our final, this is our variance. I'm sorry, this is now our variance. In order to find the standard deviation, we will have to square root 0.19. And the answer is 0.44. So now we have our standard deviation, our variance, and our mean. But I'm not done. We will have to use the second formula. Now, so let us solve for and let us use the second formula of the variance, which is variance is equals to summation of quantity x to the power of 2 times p of x minus m squared. I always use first and second formula because I want to know if the answer is accurate or not. So let us put all the value of our random variable, the p of r, which are 1/4 and 3/4. In order to do this, we will also multiply r to p of r. So multiply r to p of r. 0 times 1/4 is equal to 0, and 1 times 3/4 is still equal to 3/4, which we will have our mean still 3/4 converted to decimal will be 0.75. Since in our formula there's an x squared, we will have to square also our r. 0 squared is equal to 0 and 1 squared is equal to 1. Next, in our formula, there's x squared multiplied to p of x. We will also have to multiply r squared to p of r. So r squared multiplied to p of r. Excuse me. 0 0 multiplied to 1/4 is still 0, and 1 multiplied to 3/4 is still the same, 3/4. So we will have to summate this. 0 plus 3 over 4 is equal to 3 over 4. In decimal form, we will have 0.75. Since it said here that the summation of quantity x to the power of 2 multiplied to p of x. So here's the first part of the formula. Here we have the mean, the first part of the formula. Then, in order to get to the last part, which is to subtract m squared, we have to also square our mu, which is 0.75. 0.75 squared is equal to 0.56. Now, it's time for our final formula, which is variance is equal to summation of x squared times p of r minus m squared. So our summation of x squared multiplied to p of r is 0.75. So we will put 0.75 here minus our m squared. We will not use this because this is not squared. In our formula, it is m squared. So we will have to use this 0.56. 0.56. 0.75 minus 0.56 is equal to 0.19, which is our which is our variance. In order to look for our standard deviation, we will also have to do the same. The square root of variance. Our variance is 0.19. Then the answer is 0.44. So, in our first formula, our mean, our variance, and our standard deviation. Second formula, our mean, our variance, and our standard deviation. Let us check our second formula. The mean of our second formula is 0.75. 0.75. The variance of our second formula is 0.19. 0.19. And the standard deviation of our second formula is 0.44. Let us recheck our first formula answers for the mu, the variance, and standard deviation if they correspond or is the same with the second formula. Thus, finding them both and accurate will lead us to the correct answer. Let us check. Our mean for the first formula is 0.75. Let us input it here. 0.75. Our variance is 0.19 and our standard deviation is 0.44. 0.19 and 0.44. .19 and 0.44. So let us finally check. Mu of the first form, mu 0.5. Second form 0.5. So accurate. The variance of the first formula is 0.19 and the second is 0.19. So still accurate. The standard deviation of the first formula is 0.44 and the second standard deviation of the second formula is 0.454, so which give us 2 accurateness. So that's it. That's how we solve for the mean, variance, and standard deviation of our probability distribution that we have construct. And that's all. Sana mandugagan ng akong grado, sir.